Hello and welcome to another episode of MLOps Community Coffee Sessions. Dimitrios and I are joined today by Stefan Krawczyk. He is a manager on the data platform team at Stitch Fix. As many of you know, Stitch Fix has one of, if not the most legendary data science processes and teams in the Valley, in the world. A lot to learn from what they're working on and how they are powering all the clothing recommendations that my girlfriend gets. And she's very satisfied with. And so thank you, Stefan, for joining us.
Hello, and thanks for having me.
So, Stefan, one of the things that you said that I just want to start out with is that you and the team created Hamilton, and you chose to name it Hamilton because...
So the team that we're working with, their kind of short nickname is the FED, so Forecasting Estimation Demand Team. And we're trying to think of, this is going to be some pretty foundational piece of software for them, or like an abstraction for them. So who was the foundations of the Fed? It was Alexander Hamilton. And then because of the way that we actually approach the problem, there's a bunch of, graph theory. And so there are a bunch of Hamiltonian type things called with graphs and things. And so in which case we thought, Hamilton was pretty well placed. So pays homage to that team's name, but then also pays a bit of homage to how we're actually approaching and helping them solve their problem.
Yeah, it's a very appropriate name for what sounds like a pretty cool system. Before we jump into the entirety of that framework, I'd love to learn a little bit more about your background, your journey, and how you ended up where you're at Stitch Fix.
Great. So how far back do I start? I mean, do you guys want, from birth or just, or from time in the valley? Or
time in the valley sounds good.
But also, you've got a wild story about where you're from and how you came to be in the valley. So maybe you can start with that too.
Okay.
Yeah. So I grew up in New Zealand, immigrants to Polish parents. Did my undergrad there, and then computer science in undergrad with math, a bit of math there as well. And then I came out to the Valley on an internship with IBM. That was first foray into Silicon Valley. I was there for a year and a half. Applied to graduate school, did Stanford for 2 years, computer science, kind of AI specialization. And from there, I was did an internship at Honda Research, building a spoken dialogue system. At Stanford, I kind of focused a little bit more on the classical NLP stuff, obviously made obsolete by most of the deep learning stuff now these days. But after Stanford, I was at LinkedIn for 2.5 years on the growth side, and then on the kind of prototyping recommendation product side. Went to Nextdoor, built a first version of quite a few things. So data warehouse, email tracking infrastructure, A/B testing infrastructure, being full stack data science, prototyping a bunch of things. So Nextdoor, I got to build a couple of first versions of everything. So and then I went to a startup called Edibon, which was NLP for enterprise. That was got into the depths of trying to build machine learning on top of Spark, and then getting it accessible in a web server. And then for the last, 5 years or so, I've been at Stitch Fix, where I've been on data platforms, so engineering for data science, where I've kind of gone to build, 3 teams. So rather, I'm on my 3rd team now, and spanned everything from API backends to experimentation again to now focusing more on kind of a machine learning platform, or what we term, rather, in my team is called the model lifecycle team. So we're still called ourselves the ML team, but because at Stitch Fix, there are so many data scientists doing so many different things, machine learning would kind of alienate some teams. So we actually broaden it to be the model lifecycle team, but still have the ML kind of shortening.
Awesome. So your team, the model lifecycle team, can you tell us a little bit more about how Stitch Fix thinks about what sort of the model lifecycle looks like, and maybe kind of get into Stitch Fix's uniquely empowering mindset about data scientists? I'd love to kind of get a sense of that.
So since I've been there for so long, I've seen things kind of evolve over time. So back when I started, it was hiring very PhDs from applied math, stats, physics backgrounds, and kind of giving them the autonomy to kind of build things end to end. So they were in charge of, prototyping. So building an ETL, prototyping that, productionizing it, and then, getting whatever they were building to production, right? And so over the course of the years, the data platform team has built, more platforms and abstractions. So I want to say the data scientists still have autonomy, but they're engineering less of the things required to get things to production and using more platform tools. And so I think, the autonomy and Stitch Fix very much thinks about autonomy as a very key component of what the data science is doing, or at least the agency that they have. And so I think that means we can iterate faster because there's less people involved. If the data scientist can do something, end to end, so they can go talk to the business partner, figure out the problem. They're solely in charge of, figuring out what actually needs to be built. And then if they can build it themselves, then obviously they can give themselves better feedback as to, what's working and what's not. And so as we continue to scale, I think we're trying to figure out how we can best ensure that as things go progress into the future. And so with my lifecycle team, for instance, we're trying to reduce the amount of code that someone needs to write to get a model to production. Ideally, we can kind of reduce it to zero and make it configuration. But what do you want to dive into more?
Yeah, no, that there's a lot there. I want to hone in on one particular point, which is you mentioned that Stitch Fix has this notion of a full stack data scientist that can go identify a need and ideally themselves solve a problem end to end. This is something that we talk a lot about in the community. Is how do different professionals create business value? Where do those teams come together? And I think the specific question that I have, judging by what you just said, the full stack data scientist at Stitch Fix looks like, how do you manage if every one of those data scientists is kind of maybe building a product end to end themselves? How do you manage all those different products, or how do you manage all the outcomes that each of those fully empowered data scientists generate?
Oh, good question.
Yeah, tough question. I mean, I want to say, this answer will probably be different for organizations of different size. At Stitch Fix, we have like 130 plus full stack data scientists. And I think to be able to manage that, one is you got to be able to kind of control, I think, and measure, you could say, what they're doing. So I think having a first-class experimentation system, and what I mean by experimentation system, I mean like online A/B testing system. I know, I guess, in the MLOps machine learning world, experimentation is a bit tending towards these days to mean back testing or an offline test. So here, I mean, when something gets to production and it's being served by an API, how can you test that model is working well? And the experimentation system should enable, concurrent tests so that people aren't stepping on each other's toes. And so that's, I want to say, one core component is that you can actually push multiple things to production and people don't step on each other's toes. The other side of it, I think, is, just ensuring that there's accountability, and when something's pushed, that there is some sort of measurement. So not everything is, pushed in an online sense. Some things, happen in offline. So just having some sort of rigor around analyses and documentation and sharing out. I think this is where, if you, depending on how companies structure their OKR processes, or at least rather planning processes, one of them can be OKR, so objectives and key results. So how can you map what people are doing to objectives that the business needs, and then seeing whether you can kind of move the needle on them. So technically, I think experimentation system. Otherwise, there's a bunch of human planning and accountability, which I think is a little nuanced and dependent on the company. But at least at Stitch Fix, that's kind of how we've been doing things.
And basically, diving deeper into that, have you seen teams that are doing the same thing ever? And how do you keep from that happening?
I mean, I want to say it really depends. So yes, I haven't been doing. So I guess with Stitch Fix, there's it's a clothing business. We try to sell clothes, but we also have inventory, and we try to optimize the amount of inventory we have for the amount of clients we have. So there are, you could say, some people end up building models that are modeling very similar objectives. I want to say by enabling them to be autonomous, we've actually enabled them to be, self-sufficient in some regard, right? So this means that like if there's a bug in one code, like someone's code, but if no one else is using that model, it's only really like it's isolated to that kind of team and that kind of vertical. So I've seen it not really be an issue as Stitch Fix has grown up, that model reuse or people redoing the same thing has really kind of hampered things. Because if you are trying to iterate quickly, then the more control you have, or at least at the size that we have been for the last 5 years, it's been like hasn't been an issue. Like as we get bigger, there are some models where it's like, like they're getting really big, doesn't make sense for other teams to build their own version of it. That's where like there's this kind of, that model essentially becomes more horizontal. It's not only serving one particular vertical. So you need to kind of have some organizational maturity around process. Like how do you communicate? Do you have to know that there are downstream stakeholders and things? So I wouldn't say so. Therefore, I guess in short, I guess my short answer is hasn't been too much of an issue. I think with features and tables, that's where we're trying to actually get more leverage and reuse. But from a modeling perspective, we actually haven't seen too many things crop up. Now, this is also, I think, also potentially related to metrics and like in the analytics world, people coming up with their own definition of, LTV or lifetime value, right? So it's important that there are, potentially some team owns a central definition that everyone can kind of, understand and revolve around. But I want to say that this is a new problem in general for like data warehousey, back-endy data science teams. But so far at Stitch Fix, because of the autonomy and that we have, like we've been getting by just fine.
Got it. Yeah, I love what you said about the organizational maturity and how in a structured fashion you've been able to avoid that problem. You sort of mentioned a phrase around this idea of ML platform and model lifecycle. I think is really interesting, which is you'd like to ideally get the amount of code you have to write to deploy or create and deploy a model down to zero and have it be configuration. I think this is this idea around reducing the amount of code, increasing self-sufficiency, has been the motto or has been the guiding principle of a lot of platform teams, which we're starting to see evolve in a lot of companies. Even at my early stage company, inspired by what Uber, Stitch Fix, DoorDash, and other companies have called their platform team, we've started to think more aggressively about our platform team now. And so I guess my question, based on that sort of general observation, is over the course of your last 5 years at Stitch Fix, how have you seen that vision of getting code down to zero as the system-wide complexity has increased? How have you seen that vision sort of emerge, coalesce, and how have you been able to kind of go about that process of building the platform?
I want to say part of it is you have to kind of, I guess one nice thing is that my team is, engineering for data science. So we're not beholden to kind of any other kind of real stakeholders. Our stakeholders are the data scientists. We're also not on any critical path necessarily, because we try to give the full stack data scientists autonomy, in which case we're trying to avoid handoff. And so therefore, like in some sense, it's actually reasonably easy for us to start something new and try to get people to adopt as they do new work, right? And so this has, you could say, we're not necessarily burdened with how data scientists have been doing it previously. We can think entirely about how should we be doing it and what are the steps to take it, right? And so, so this means one, we need to kind of be able to communicate this kind of vision, and then find what I think has been successful, or the most successful way for us to kind of approach this is to actually find, be able to really understand what the data science or the processes that data scientists are doing, and try to figure out like what is the most impactful things that we can kind of abstract and or what are the core abstractions that we need to really kind of get at the zero code, get to zero code to get something to production. So this hasn't been a quick thing, right? We actually, in terms of our journey, we actually started when I first joined Stitch Fix, it was really hard to spin up APIs or backend APIs. So we kind of, rather than focusing on modeling, we actually focused on how do you make it really easy to spin up a backend API. So before, people were writing Flask apps, and instead we wrote a little abstraction on top of Fast API where we abstracted the web service and instead just enabled people to think about functions, right? So we took, you could say, if you think from a layers approach of how to do things, we started at the outermost layer of like serving online predictions. How can we kind of abstract that and make that easy? So with that, and then with experimentation coupled together, we made it really easy then to kind of experiment and deploy things on in production from an API perspective. Then we started down. So Hamilton was a specific case for a specific team, so we focused on that. But otherwise, since then, we've actually features in a more general kind of centralized featureization kind of problem is, I think, one of the hardest ones to tackle in the zero code thing. So we've actually left that to be. We're now thinking about it now, and before that, we actually decided that we really needed to understand what a model is to be able to get to the zero code thing. So knowing how we can get something deployed, because we've kind of made the deploying a backend API or a model in an API very easily. We then kind of thought about how can we actually automatically generate that code. And what we decided or figured out was that we really need to understand what a model is. So what are the model's dependencies? What's the model kind of API input schema? And then how can we make this configuration driven? So that's kind of the starting points. I can keep going, or do you have questions while I'm still thinking about what to say next?
No. I mean, I feel like I threw a very general question at you, and you handled it like an absolute pro. I think some of the things that really I enjoyed hearing about from you are that number one, stakeholders being the data scientists first and foremost. Maybe not necessarily the customers at the end of the pipeline where they actually get their close, but really the data scientists. And the corollary of that being that you're not necessarily on the critical path. I think this is kind of it's an interesting thing to be on a software engineering team, but not necessarily associated with the core delivery of the product itself, but kind of working adjacent to that. Because your rhythm is very different. The timelines that you think along are very different. And it's actually very helpful, to hear that this is the way that you manage that element of building a platform.
Yeah, I mean, part of the once they are on our platform, obviously we have have to keep production SLAs, but at least from a starting perspective, it's really core to really find the right data science team to work with to get them and validate what you're building, and so co-develop with them. And reduce the pain point, because then I think it's like it makes us look good because we have a win on the table. Hey, look, we helped this team. That team feels good because they got something at some pain point removed, and then that gives us then more credibility to then expand and like look at other teams to kind of, hey, can you adopt our stuff?
I've got a quick one that is a little bit of a tangent, but I keep thinking about it. And if you're enabling all these different data scientists to effectively go out and solve their own problems or solve business problems, have you seen it? And of course, you can always deny answering this question. You can plead the fifth. Mm-hmm. But have you seen where that freedom and that autonomy has gone wrong? Whether or not that has been that they've consumed a ridiculous amount of resources for the problem that they're trying to solve, or they just managed to introduce a bug in and it threw a jackknife into everything that it touched. Have you seen any kind of war stories or major fuck ups?
Yeah, I mean, so there's the quote of like. I forget how it starts, but essentially, they essentially had we essentially gave data scientists keys to AWS, right? And so, with great power comes great responsibility. And so that's the kind of the attitude and cultural attitude we have. And so, I don't think it was through any malice or anything that like anyone did anything on purpose. But when we made something really easy to do, some people took us up on that offer and really used it. So, like backing up the Spark cluster because we make it really, really easy to backfill something, right? I mean, so it's nothing bad or egregious. Just by making something really easy, some enterprising data scientist can go, oh, okay, well, let me try this for loop and like spin off 1,000 jobs at once, right? So that's the kind of, I think, things that come to mind. I mean, the other kind of quote I like to say is, process exists when culture breaks down. And so when an API design, someone who's without too much experience, right, doesn't necessarily know the best practices for things. So we've had to, institute a bit more of a process here on it being cultural of like, hey, you design the API rather, hey, you should get the API checked and like this other team needs to sign off, right? That's kind of something we've had to learn along the way, but I think that's kind of reasonable because it's not fair that we can, assume that every team knows how to design APIs well, especially if they're not from a software engineering background.
Yeah, that makes total sense. And so always useful to get those war stories. Demetrios loves those, absolutely loves them.
Yeah, I am a sucker for it.
I mean, I want to say they're usually the applied physicists are the ones who usually figure out how to abuse the system. So.
Always those physicists.
Something about their education.
Yeah.
Something about it. So we were researching Stitch Fix a little bit, Demetrios and I, and as we understand it, you have a data platform team, which is, as the famous blog post puts it, is aggressively helpful. And then you have, as a subcomponent of that, or like a sub team within that, is your model lifecycle team. Is that correct?
Yep. So platform team, we have a bunch of teams, but model lifecycle is one of them. Yep. Okay.
What are some of the other sub teams? Just curious.
Yeah. So we have a team that's focused basically on like compute infrastructure. So looking at the Spark cluster, Presto, how do you distributed compute, and so they take care of distributed compute, Kafka, and then how things are stored. So essentially, data access, how do you get it to some compute, and then provisioning that. Another team focused more on like you could say. Workflows and kind of environments. So how do you build a Docker container? How do you build an image? How do you create a workflow and get it kind of scheduled and executed? And then we have a team that's focused on we actually have you could say a UI, I guess like a UI UX team kind of internally. But the UX that they're mainly focused on is data visualization. So we do have we have an awesome team that helps spin up kind of internal dashboarding or provide internal kind of React tooling to make it really easy to kind of spin up some sort of front end to visualize some data, which is a common need that data scientists kind of have. I have another team that's focused more on like this backend API, kind of sort of this interface layer between the algorithms kind of organization and kind of the wider business. So they kind of take care of that, build tooling and infrastructure for that. And then we have the experimentation team, so centralized. So they handle centralized experimentation for the company. So they have the most traffic service, and then they have the front ends to kind of turn on experiments and kind of plot results and does that cover all the teams? I think. Okay. And then we have a data eng team. So we have like as we've grown bigger, we've actually had spun up more of a data eng team who then own some core kind of data model abstractions within the data warehouse, and so and then also provide you could say self-service access through Looker to like BI tools. So we've also spun that team up as well.
Very, very helpful. So this is the big picture of data platform, and model lifecycle sits within that. And so, as you kind of mentioned, your mandate is really focused on this idea, and correct me if I'm wrong, of like create and deploy models easily. Is that correct?
I mean, I forgot I don't think I actually said it, but essentially the mission of the team is to streamline model productionization for data scientists. So anything we can do to streamline their process of getting a model developed into production.
That's awesome. So now, I would love to dive into some of the specific projects that your team has done around that model productionization work, because that sounds like a pretty interesting challenge to define across the life cycle of very different models, maybe that serve different needs of the business. Is that fair to say?
Yep, totally. I mean, Stitch Fix, we have people doing time series forecasting, neural net stuff, matrix factorization, your regular logistic linear regression, constraint optimization, and simulation. And so they're all models. They all want to be tracked. They all have some sort of notion of metrics. So yeah, trying to build some platform that can enable all of them to use it is kind of what we're trying to do.
Man. And so if you had to give an example of a project that your team worked on that, you're most proud of in terms of how it really helped that process of model productionization, what would you say?
Good question. I mean, I like everything my team does. So it's, hard to pick favorites.
There's a diplomat. He is very diplomatic, isn't he?
Hard to pick favorites. I mean, I want to say, so Hamilton is a nice, cute framework for featurization for time series forecasting. And then there's model envelope, which is our core abstraction for capturing what a model is and then being able to auto-generate code to get it to production. So I would say those two are the two things that I'm most proud of thus far. But
yeah,
if you want to talk models and like zero code, then I think model envelope is where we should go. If you want to talk about DAGs and like a different way of creating data frames, then Hamilton is where we can go.
Well,
I would love to talk.
Independent of what Vishnu says right now, I'm going to cut him off real fast. And I just want to know about Hamilton, because the last time that we spoke was at the Apply conference where we met. And you mentioned that Hamilton may be open sourced. Any updates there?
Yep. So I've engaged the internal process, just waiting for a few more boxes to be ticked. So for instance, legal, but otherwise, looking to try to get that out as soon as I can, as fast as our internal process allows us. But very excited to try to open source it and get other people to use it. In short, I guess Hamilton is a micro framework for creating data frames. And so what essentially it does, the TLDR, is that it changes the way that you can kind of create a data frame. So rather than so for time series forecasting, you need to create a data frame with a bunch of columns with, at Stitch Fix, it's thousands of columns wide. Managing the code base to do that actually gets pretty cumbersome. And Hamilton, what really does is enables a team to really manage that process really well by focusing on building functions. And the framework then builds a DAG, then can build the data frame for that team. Hamilton can then build the data frame that's required by that team for use in time series.
Yeah, I'm pretty stoked. I know there was a huge amount of reception, or a very warm reception, for the idea of it to be open source. So keep us updated. Once it is open sourced, please let us know, and maybe come back on after a few months of it being open source, and you can teach us how different of a beast it is to open source something or just have it within the company. I know that they are very, very it's not like diametrically opposed, but they are different to work with, we could say.
No, this will be like, I guess, my first real experience open sourcing something. So definitely, probably we'll have something to chat about.
Right on. Now I get the feeling Vishnu wanted to go down the other route, though.
No, I mean, I will say Hamilton sounds like a very impressive piece of engineering. But the reason I'm interested in talking about model envelope is because I actually had to work on a model deployment system. And so I would love to just kind of talk a little bit about, how you guys are thinking about the model deployment and just go through that process overall. And so maybe we can start with like the same way you summarized Hamilton. Could you summarize for us what model envelope really was and what it meant to the team?
Yeah, so it's the model envelope, I guess, in a nutshell, is a container. So that's hence why we use the term envelope. So it's a model and a bunch of things that we can put into an envelope and then ship it and send it to production is kind of the metaphor we're going for. And what it essentially entails is the data scientist uses an API, much like MLflow, to save the model. That turns up in a registry. Then they just need to kind of click a few buttons, provide some config, and they can get that model kind of deployed to production via an API or insert it into a batch workflow. But essentially, it enables us to kind of think of the model as a black box. So we know the inputs, the outputs, in what environment that's required to run it.
Got it. And so essentially that process of specifying all those inputs and outputs and everything and thinking about, how the model is used in the end use case is kind of abstracted away for the data scientist.
Yep. Yeah. So we tried to, so we grew up, we started this project around the same time as like MLflow was kicking out. There's another project, ModelDB, which is, I guess, the predecessor of MLflow. TensorFlow Extended has also come out. They have a nice, you could say flow chart of the different steps that they have in their model deployment pipeline. So essentially we're thinking of what were the problems we had internally, but then also thinking about looking at where industry was going. And so we took a bunch of ideas from those projects and incorporated them into the model envelope. So we wanted to make it super easy to kind of, save the model, and then deploy it. But then we also wanted to kind of decouple deployment. So we encourage any and every model to be saved in the model envelope, even if you don't know it's going to go to production. So we wanted to, that enables a bunch of other things that we can kind of do. But really, I think from an ergonomics data scientist standpoint, we wanted to like have them focus on the model, and then when they want to take it to production, we, just because we know what the model is and what the API inputs are required, that service that actually ends up getting deployed is really simple because it's only about the model. It's not within some business logic, etc. So it's actually then pretty easy then to put into some production workflow without knowing the context a priori, because that's not required.
So before Vishnu jumps into more technical questions and pillaging your brain for all this information for his next project, I want to ask you about something. I know we've talked about this before, but we weren't recording when we talked about it. And I love what you say about this. It's like deployment for free, I think is how you put it. And that is just a great way of explaining what exactly you're trying, like the vision there. But as you mentioned, you were creating this when MLflow was coming out. Also, TensorFlow Extended has come out. Has there been a moment since you created it that you've thought, we need to jump ship because MLflow or TensorFlow Extended is doing this and we like the way that they're going? Maybe we should just outsource it and bring that on.
Yeah. In all honesty, no. And the main reason is because it's much easier to integrate with our internal tooling than it would be with those kind of options. Now, we do keep tabs on terms of features and other things and thinking how they're doing. So for instance, I actually think the TensorFlow data validation module is pretty awesome from like a perspective of what it's trying to do and the schema that it sets up for that it then uses downstream to determine API validity and are the inputs being is the right data making it to the API. What are the kind of bounds of data that should be expected? I think so. It's a nice thing about, I guess, in open source code and other things is you can kind of look at the internal details and really kind of try to understand what they were trying to solve. So I think since we actually had, so MLflow since then has, for instance, added the ability to, you pass in a data frame and it introspects the API, because before it didn't do any kind of, API validation. So it's nice to actually have some of our internal ideas validated, I want to say. So that's made us feel good that we made some reasonable design choices, right? But the main, you could say, one of the things that I think is key to us is that we actually wanted a really easy way to tag models. We didn't want to institute any hierarchy because we wanted to make it really easy for not just an individual, but a whole team to manage a suite of models, or a manager to quickly understand what's happening. And so we really needed a different approach to you could say model management. And so because of that, I want to say, like, no, we haven't gone, oh, damn, we should have, used them instead. But for the most part, we've actually, developed things in parallel and had our ideas validated, which has made us feel good.
Got it. Interesting. And so as I'm just,
TensorFlow Extended is pretty, I want to say is a pretty good standard to reach for, but unfortunately, not all our models, and not everyone wants to use TensorFlow. So that's also one of the reasons why we didn't go down that route.
Exactly. It makes total sense. I mean, you have very different modeling use cases. And so that kind of leads me into my question, which maybe might be a little bit more of an exploration. So I'm a data scientist. I've written some modeling code. I pulled some data, in some format. I come up with a model. It has this performance. And I'm like, okay, Stefan, I want to use what you're telling me I should use this ML envelope. Seems like our company standard. How do I actually use this ML envelope on my model artifact?
Yeah, we try to make that that as simple and easy as possible. So one is making it the installable dependency being pretty nice and light, so it's not trying to pull in like different libraries and things, because it's pretty agnostic to that. And then it's 5 lines of you could all write it in 1 line of code, but if you want nice looking code, it's going to be a few lines. But it's clean code, it's going to be a bunch of lines. And so essentially, just want to make it as cut and pasteable as possible as well, so that if someone sees it in someone else's script, they can cut and paste it, and generally it should just work. Like, they don't have to tweak too much about it, because most people start projects by cut and pasting the previous one. So we wanted to ensure that like it was clear from the API description, or like at least the parameters that are passed, that like people can understand what it's going for. But we try to make it as simple as possible. And so other frameworks, for instance, get you to then also have to have like a deploy step in that same script. We, explicitly remove that because we just wanted to make it super simple, that if someone just had a model, just need to add these lines to the end of your script and it should just work.
Wow, what an elegant workflow. Okay.
Yeah. I mean, because the other thing is we try to also introspect as much about the environment that the model is running as possible. So as opposed to other APIs, you need to pass in, these are the Python dependencies that are required. We instead, snapshot that and try to do some reasonably, pseudo-intelligent things to determine like what is the actual set of dependencies required for this model. So therefore, we also try to make it so that nothing has to change as the model evolves over time. You don't really have to change the API signature or what's passed into the API, because it should just work.
Okay, so let's say I'm working on a model. It takes in 5 features. In my API spec, right? I take in 5 features. Like the age, height, gender, whatever it might be, and I return, okay, you should have this clothing item. But then after some additional research, 6 months later, I come back and say, Stefan, it's a new feature. We've actually discovered that, which color eyes you have are really important. How do I extend the API definition in model envelope for my model?
Yeah, so that's kind of where I was saying that, like, hopefully the way that we structured it with what the inputs are required, that it's always going to be correct. You don't have to do anything. Maybe it's only on the API deployment side that like the actual, you might have to do something there, but so for instance, if we introspect the function, so if the predict function is like Python primitive, so there's no data frames, it's all like ints, floats, and things, like we take that as the signature for like the inputs for your model. So if eye color becomes a new parameter in that function, we will automatically figure that out, and that's captured in the new model. Else, if it's in a data frame, we actually require you to pass in example data. So as long as, and ideally that example data is actually what you use for training in its simplest case, in which case that's always going to be up to date. And so no code change required there. It's only on like production integration where like if no one's passing you the eye color feature, there'll be an issue, but then that should return, like a HTTP 400 result or something like that. So we should, so therefore very much focused on, how can we make this very low maintenance and always correct? Got it.
So once I've packaged up my model into the envelope using the 5 lines of code that basically, describe, I'm assuming, dependencies or as you said, snapshot dependencies, and I guess do some kind of validation of the API. Is that correct?
We haven't, so not strictly, it really depends what validation you want to do, right? So like validation really is kind of a little potentially, context dependent and where you want to deploy it. So in our mind, it's probably should be more part of like the CI/CD step before deploying, but we enable you to log metrics and other things as well. So if you want to, not just that 5 lines, you add a few more lines to log metrics about the model, then we also capture that and then store that. So it's kind of, validation. We haven't been opinionated in Model MLOps, but we have the constructs there to be able to do, to enable whichever opinionated way you want to do things and just have it work.
Fascinating. Okay, so now I have deployed my model. You've told me how I can actually extend the model as well, which is, hey, Vishnu, don't worry about it. Now I'm curious, kind of zooming back into the platform engineers sort of thought process. Okay, now all the data scientists are actually deploying using this standard format. How have you built on top of that to maybe enable, monitoring at scale? You mentioned model management using the tagging. I'm curious, like where you've been able to build on top of this in other elements of your infrastructure.
Yeah. I mean, like, so with tagging, right? So the way that we've divorced, saving the model and deployment is that we then have a system where people essentially use tags and some operation. Basically, they come up with a query. So the things we can query over anything about the model and then determine whether it's an eligible candidate to be deployed. So whenever a new model is written, we go, oh, look, does it match any of the current kind of rules that are required to deploy something? If so, we then kick off a deployment. In that process, right, we can, so once things are saved into an envelope, the only things that are really mutable are tags and metrics. Everything else is kind of static. So each new model saved means a new deployment, a new model instance ID, but you can update tags on it. So this enables us, for instance, to have, to your validation kind of question, like they can save the model with a bunch of tags saying, hey, this was trained. They can then kick off a second thing that like pulls that model and does some validation, pulls it, I don't know, scores it, etc. And then they can add another tag saying, hey, this is good for deployment. In which case then, as long as they've set up rules to kind of, look for that particular tag on that particular model, then that will then qualify it for deployment. So that's one thing that we build on top of. We also have, I guess, the tags function also enables us to build, it give people a way to kind of query for their models using kind of, whatever tagging system they've come up with. So we haven't actually been very opinionated on tags purely because we wanted to this to be pretty organic and to figure out the right processes, human processes of like how a team should organize and do this model. So We've been pretty flexible there. But in terms of building on top of, we store the API signature, and then if we're given data, we also have expected data shapes and distributions. We are in the process of connecting that to like the online side of actually capturing things on online so that we can determine, do we have training serving skew? We have the hooks in place. We auto-generate the service. We can log the things that we need. So that is kind of things on our roadmap that we're actually getting to in the next kind of quarter or two. But what else have we done? We also enable, batch deployment. So you can kind of, anyone can put into their workflow someone else's model as long as they know the tag query required. And it will always get the latest model when queried, or if you know the instance ID, you can use that. So we've kind of also enabled it to make it easy for other teams to use other teams' models in an offline context.
That is awesome. So much that you've enabled by just defining what a model is and how it will work in a number of different settings. And so that observation right there, if you were talking to a more junior developer, let's say, or somebody that was maybe in an earlier stage system where modeling is still kind of an emergent use case, maybe someone named Vishnu Rajachanda, what advice would you have in terms of the process of, because I'll share my challenge candidly. When I was building a model deployment system, it's like, you have your glue code and you have the model itself, right? And it's like both of those kind of evolve together, and how you actually kind of have this like neat abstraction where you can just say, okay, this is where whatever the model is required to kind of slot in, or this is the envelope that encapsulates that is not mutable. That was always hard for me to define. How did you guys actually go about like saying like, this is what a model constitutes? Right. I feel like that's a pretty hard challenge. Like how did you guys do that?
I mean, essentially, if you can serialize it, if you can serialize some bytes then essentially it's a model. Like we're actually, I mean, you could write a plain Python function and serialize it, and it would just work. So we were on purpose trying to be very agnostic. The only requirement was like, can you serialize it in Python early on? Now we do have hooks to make make just different frameworks have specialized serialization formats. So we do have hooks to like enable that. But essentially, getting started was like, if you can use Pickle or Cloud Pickle to serialize it, then our framework can serialize it. Because it's Python, you do need to give us like a pointer to the function so we can actually ensure that like this is something that we can kind of call and execute. But that was essentially all that we required. Is like, hey, it's some function that we can execute. Essentially, kind of how we were thinking about it. And it just so happens that Cloud Pickle, a lot of model frameworks and other things can be serialized pretty easily that way. There's a few that can't, so TensorFlow being one of them. But yeah. So that's kind of we've tried to be as agnostic as possible. Now, the other side is like Python dependencies are really generally where people get caught up, right? So you have to be super strict on, or at least be able to capture those dependencies properly, right? And on the production side, we're just going to make sure we have tooling that doesn't really conflict with the Python versions, which isn't the hardest thing to do. You just need to keep, as long as you know what versions you have of things and where things conflict, then you can at least, if a conflict does arise, it's easy to track down so you can fix.
Got it. Okay, so is it fair to say then, as a final question before I kick it back to Dimitrios, that envelope is a little bit, you could say is more constrained and more specified, well specified than a container?
So we build on top. So basically, so we assume, we make a base assumption that everything runs on the same kind of base Linux kind of version, right? Okay. We track, what Python version it was run on, and like ensure the container has the right Python version as well. So I want to say, like, it builds on top of Docker. So like eventually we create a Docker container, but essentially this enables us to use that model in any context. We could create a PyEnv environment locally if we wanted to with the same information. So I want to say it's like it goes hand in hand with it, but it doesn't we don't capture necessarily the C or underlying dependencies. Right. We make a bit of an assumption that there's a common base layer, but otherwise it's pseudo like that, but not entirely.
Right. Okay. Makes sense.
So zooming out a little bit and coming back to the whole vision and goal for this that you talked about in the beginning, in that you're trying to speed up the time to development and the time to production. Do you have numbers around how this has helped and what the benefits have been?
Yeah, that's always a challenging question for platform teams. Partly in that you have data scientists, and at least in our case, we have data scientists who are building very different models and also have very different tenures. And so it's actually from if you were to measure time to do something, you'd have to ensure that you're comparing similar data scientists to each other, and so that's gathering that data itself in of itself is challenging. I want to say the other side that I think about is actually who would be very disappointed if they couldn't use Model Envelope, and everyone who uses us really enjoys and likes us, and actually gives us shout outs because we made some part of the process much easier to do. So what we instead look for is you could say net promoter score type thing of would you tell another colleague to use us? But we do track the amount of models created. That's obviously it's a vanity metric, because if someone's doing back testing or something, they can create 1,000 models in a day. So it's we can't track that as an absolute number. So we actually been tracking more team penetration and how many teams are using us, how many services are deployed, and that's nice kind of linear growth of over the course of quarters, because that's just how people develop, and that's the pace of new things cropping up. So as long as our metrics are generally tending upwards and towards the right, and people are happy, that's kind of our success metrics thus far. But I'd love to be able to quantify that more easily, but it's just a challenging problem.
I think that makes perfect sense. I mean, I think, at the end of the day, yeah, as you said, there are all these confounding factors, and, people are using a tool that is the greatest, endorsement that they can give. And it certainly sounds like that's the case. And thank you so much for taking us through the model envelope sort of use case. It feels a lot like we've learned a lot about what platform teams actually, how they can actually enable, better data-oriented and machine learning-oriented workflows through the right kinds of abstractions. And that's always something that, we're talking about in the community. And with that, thank you so much, Stefan, for joining us and sharing your knowledge.
Thanks for having me.
This was awesome, man. Yeah. And I'm going to have to recommend, or I will nominate you as the best background guest with the best background that we've had. So if you're just listening and you do not see Stefan's background, you might want to just pop over to YouTube and check out what he's got as his background, because it is insane.
And so if anybody, wanted to maybe read your blog posts or, look at your content around Hamilton or model envelope or anything else, those slides are available publicly. Is that correct?
Yeah. So I have a SlideShare account. So if you look me up on SlideShare, you should be able to see all the presentations I've given. Otherwise, I am in the MLOps community Slack, so also happy to take questions there.
Yeah, and we'll link to your SlideShare in the description. And if you all listening enjoyed this, give us a thumbs up, like it, all that good stuff, whatever the cool kids do these days to show some love to this.
Still is a thumbs up, Demetrios. It still is a thumbs up.
It still is? All right. I didn't know if we needed to TikTok or something, or do a special podcast to show the appreciation. Anyway, we're getting a little ahead of ourselves. I think it's time to wrap. Thanks again, Stefan.
Thank you so much.
Thanks again, guys.